Welcome back to my channel. If you're new here, my name's Kai. I want to showcase the project I built for the Nomba Hackathon 2026. So basically, what I built is called Rails. So Rails is the dedicated virtual account infrastructure on Nomba that has per customer provisioning, inbound transfer reconciliation, and a clean webhook API for downstream teams. So basically, if you're wondering what does this solve in the Nomba ecosystem, how is this useful? So to give context, Nigerian teams, when building products, they always have to rebuild the Nomba virtual account provisioning, webhook verification, and reconciliation on every project. So Rails does this once for you as a managed infra. So that's basically what Rails is. So Rails is a developer-first virtual account infrastructure layer built on Nomba's API. So for this demo, we're going to be using school fees collection flow. So each student will get a dedicated Nomba virtual account. Inbound transfers are reconciled to that student, and the school can fetch a clean ledger or statement from Rails. So Rails comes with these endpoints: the customer's endpoint. This creates or updates a student or customer. The customer ID accounts endpoint. This provisions or reuses a Nomba virtual account. The webhooks. This verifies the Nomba HMAC signatures. It accepts virtual account transfer webhooks and enqueues the reconciliations. The transactions endpoint. This returns paginated transaction history. The statement. This returns date filterable statement tools and roles. The webhook subscriptions endpoint, this registers downstream callback URLs for signed Rails events. And the docs, this serves the Swagger UI and the documentation JSON, and it serves the Open API document. So now we want to look over the security and the architecture of Rails. So you can find that in the docs folder here, architecture security.md. So for the tech stack, I use Node.js. So I use the Fastify API framework with TypeScript. For validation and config, I use Zod. For the ORM, I use Prisma. For the database, I use PostgreSQL. For the background jobs, for the queuing, I use BullMQ. The Redis client I used was IO Redis, and the Redis hosting for production I used was Upstash. For the external integrations I made, the Nomba API, for payments, for the auth client credentials, for the virtual account and the inbound webhooks. And for the webhook security, use the HMAC SHA-256. So this handles both the Nomba inbound and the Rails outbound. For authentication, I used API auth using API keys. For the admin bootstrap, that's a one-time token for creating additional API keys. For the testing, used Vitest. For the hosting, for deployment, I deployed on Render because the free tier is quite generous. Then use .env locally, and then render environment variables for render. And then since the free tier of Render sleeps and I need to be on the lookout for webhooks, I used Uptime Robot that pings my health endpoint every 5 minutes to make sure the server is still active and I can receive my webhooks. So now for the Rails architecture and security, is a Fastify TypeScript API plus BullMQ worker that turns Nomba virtual account transfers into customer level ledger entries. So this is the diagram. The downstream app uses the API key, makes contact with the Rails API, gets the OAuth token, the Nomba API, a payment success. The webhook receiver, it goes to the verified job, enters the Redis and the BullMQ, enters a reconciliation worker, outbound webhook worker, and then to the downstream URL. So for data handling, we have customers, the core tables. We have customers, virtual accounts, transactions, reconciliation events, API keys, outbound webhook subscriptions, and the outbound webhook delivery log. So for the inbound webhook security, Rails verifies every Nomba webhook before enqueuing. So the HMAC SHA-26 payload uses this. For the API key security, this is what we use for authentication. So we authenticate with authorization, the bearer, then the key, or X API key. So Rails only stores the SHA-256 hashes and a non-secret prefix. For idempotency, the inbound transactions are deduplicated by Nomba, transaction ID, and session ID. Provisioning is idempotent at the customer level. If a customer already has an active virtual account, Rails returns it instead of creating another one. For outbound webhook security, Rails signs outbound webhooks with Rails webhook secret. So the deliveries include the Rails event ID, Rails event type, Rails signature algorithm, the Rails signature version, and the Rails timestamp. For reliability, it's the webhook Nomba webhook ingestion returns a 200 after verification and in queuing, avoiding repeated Nomba retries during normal operation. BoolMQ retries reconciliation and outbound webhook delivery with exponential backoff. So the database unique constraints also enforces idempotency even if workers retry. So for the sensitive configuration, these are the variables we have in our env, and in the render env for production, the database URL, the Redis URL, Nomba client ID, Nomba client secret, Nomba parent account ID, the Nomba webhook secret, the Rails webhook secret, and the admin bootstrap token. Okay, so demo quick start, how to get up and running with the project. So first, you create an API key. The first key can be created without a bootstrap token. Later keys require the bootstrap token matching the admin bootstrap token. So you can run this in your terminal. This creates your API key that you use. So the tenant ID can be demo school and the label can be demo school. Then when you want to create new API keys after this, you would need to put your admin bootstrap key right here. So then you create a student or customer. So this is creating the student. So you can create the name, can put the email, the expected amount. So this is like, let's say the amount of school fees they actually have to pay. So that's the expected amount. Then you provision the student's Nomba virtual account. So Rails calls this Nomba endpoint, and then with the parent account ID header and your Nomba sub account ID in the path. So basically this creates the virtual account for the student. And then once you've done that, you need to register a downstream webhook receiver where you receive your webhooks on webhook.site. So you go to this website, you copy your URL, and then you use your Rails API key that you got from here. You put your Rails API key, and then you put that URL right here. And then, so the event is looking out for is transfer.matched, .underpaid, overpaid, and misdirected. So just to give a quick overview, this is what the webhook.site looks like. This is what it looks like. So these are the requests, the webhook requests coming in. Yeah. And so now then to fetch the student statements, you can use this, and then you can also fetch the transactions to see the transactions they just had. So now let's go to the Swagger UI. So we can see the Swagger UI here. So we can test the health endpoint to see if it's running. Uptime Robot is keeping it running, but let's just do this. So service true, Rails, it works. So now I want to show a previous transaction I did where I transferred money to the live account, the live Nomba student account that was created, and I got a webhook and the money actually went through. So I want to show that transaction of how I did it before. Would go to the transactions endpoint. So first we have to put the API key. This was the API key I used before. Okay. And then the student was called student 003 200. So this was the transaction that I did that was live. I sent it through Opay. I'm going to blur out some sensitive information But yeah, so the expected amount that they would know that the student, we're using the school fees analogy. So the expected amount they were meant to pay, 150, the amount that was actually paid, 150. So the status was matched and the event type was a payment success. And if we go to our webhook.site to see the webhook receiver, you can see that it was a matched transfer with an amount of 150. This is when it was paid at. So the reason transfer amount exactly matched the customer expected amount. And then there's the Nomba transaction ID and all that. So basically, I want to also show now what if the person underpaid, but this time I'm not going to be transferring actual money. I'm just going to simulate the webhook. Okay, so you can see the Rails database using Postgres. These are all the tables. So now I want to show if we underpaid. So basically I'm going to run this curl command. I'm using this script. You can find it in the code base in the GitHub. It's to replay a signed number webhook against my database, either local or hosted. So I want to test this. Oh, sorry. Okay. So you can see it's posted. Okay, so you can see it posted signed demo webhook to my webhook/number, and 200, it went through, it was received, and it was queued as true. Okay, so I want to show, you can see that it has been received and it has been queued to the Boolem queue worker. So now I want to check for the transactions. I believe I can do that from here. Come to the transaction, it's still the same student. So yeah, let's get it. So you can see now, this is the new transaction we just did. It's demo. You can see that it doesn't have an actual number transaction ID because this didn't come from Nomba. But if it did come from Nomba, it will still be the same outcome. This is a demo on the pay for this video. So the amount that we sent was 100. The expected amount was 150. So you can see the status is underpaid. The event type was a payment success. So you can see the sender name, demo parent to demo bank, and the narration is demo school fees payment. So with that, we've come to the end of this video. If you found this useful, please be sure to like and subscribe and leave a comment below. I will link the GitHub repo in the video description. So fingers crossed, I win the Nomba 2026 hackathon. Thank you all for the opportunity, Nomba DevCareer, to be able to participate in this hackathon, and I will see you all in the next video.